This is my video on fatigue and recovery. So, the causes of fatigue. There are three main causes of fatigue. The causes are a lack of an energy source, waste products, and neuromuscular fatigue. And we'll go through them in later slides. So, fatigue will be displayed through many symptoms, and different symptoms will be shown in different sports. And there are lots of ways of preventing and delaying fatigue. Creatine is in the body naturally. It's stored in the muscle sarcoplasm, so it's available at all times for the muscles to use, as long as the stores in the muscles aren't depleted. It's very quick to run out because the body's natural store is very small, and to try and increase phosphocreatine in your muscles, you can take creatine supplements. Research done by Greenhalgh, Bodin, Soderlund and Holtman in 1993 found that oral creatine ingestion increases the total concentration of creatine in the muscles of those individuals who have a concentration close to or less than 120 millimoles a kilo of dry matter before ingestion, which means that the taking creatine supplements will increase the amount of creatine in your muscles. So 100-meter sprinters are going to be most likely to benefit from this fuel because it's quickly available and there's enough in your natural stores to last about 10 seconds, which is about the length of a professional race. So you should only need to use creatine, and you shouldn't need to use the lactic acid system to produce energy for the race. Whereas rugby players will use creatine for sprints, but there is then a chance for short sprints, but then they have a chance to recover, where the aerobic system will resynthesize the creatine in their bodies so that it can be used again for other sprints later in the game. So, creatine is, on this table, you've got, these are the results from a group of people who did Wingate tests. So, if we look at the peak power output, this will have been reached using using creatine as a fuel. But as your creatine stores decrease and get smaller as you use it, you're going to start fatiguing more, and this is shown by your fatigue index. So the fatigue index is displaying that as your creatine stores decrease, your lactic acid system is going to start working, and the more this has to work, the more lactic acid you're going to produce. So the lactic acid will stop your muscles working as well and will make them fatigue a lot. So the longer you can use creatine for, and the more creatine you have in your muscles, it will mean there's less time in the test that you'll be using the lactic acid system, so your muscles are going to fatigue less. So if we look at Ellis, he has a low fatigue Ellis Chapman has a low fatigue index, only 40%, as he has a very little lactic acid in his system, in his muscles, which will be because he hasn't used the lactic acid system for very long. So this then implies and shows that he has a much higher natural creatine store than some of the other people that have taken the test. Whereas if we look at Charlie White, he has a much higher fatigue index than Ellis does. His fatigue index is 81%. So this would be because he has a lot more lactic acid in his muscles. Because he'd have more lactic acid in his muscles because his lactic acid system would have been working for longer, which then implies that he has a much lower and smaller creatine store in his body, which will cause his lactic acid system to start working sooner. Glucose and glycogen are two other fuels that the body uses, but they will only be used in the lactic acid system and the aerobic system. So the body has large stores of glycogen in the liver, which is then processed and broken down into glucose, which will travel around the body, dissolved in the blood, and can then be used by the muscles to produce energy for a muscle contraction. In exercise, for example, a marathon, there's a phrase known as hitting the wall, where you suddenly become very tired and fatigued, and this is because your body's run out of glycogen, so it's run out of its biggest fuel store, and then has to start using muscle proteins and fats. So when the body runs out of glycogen, it will start using muscle proteins as a fuel, and this when the body runs out of glycogen, it's called glycogen depletion, and this can lead to muscular atrophy, which is where the muscles will be getting smaller, and this is because gluconeogenesis is happening, which is where the body uses muscle proteins to create energy for muscle contractions. So you've got muscular atrophy because the proteins from the muscles are being taken away, so the muscles are getting smaller. And it can be delayed or avoided by a carbohydrate-rich diet in the days preceding a big event that you're going to be taking part in. And a high carb diet before an event is known as carbohydrate loading or carbo loading. So you're really building up a massive glycogen store before a big event. Also, if you're in the middle of an event, you can take supplements to help replenish your glycogen stores. So you can take carbohydrate and glycogen gels that are really, really high in glycogen and will give you a lot more energy for the rest of the race. So the main use of this in sport is in a marathon. So you'll carbo load for a week before the event, eat a lot of carbs to build up your glycogen stores so that you've got energy for a lot of the event, and then at regular intervals, say every 4.5 miles, 4 miles, you have a glycogen gel to help keep up your glycogen store. So now we're going to talk about the effects of waste products and how waste products make your muscles, make you fatigued. So CO2 is one of the waste products that we produce in the muscles when we're trying to produce energy. The more the muscles are working, so the more you're exercising and the higher intensity you're exercising at, the more CO2 you're going to produce. It's not very harmful to the body, as we can remove it naturally through regular expiration, and it's only produced as a waste product in aerobic exercise, so it's not a massive problem for the body. So it's easy to remove. We can remove it. It's removed from the muscles in 3 ways. It's dissolved in the plasma in the blood. It's transported as carbonic acid in the blood, and it transported as carbaminohemoglobin, which is CO2 attached to a hemoglobin molecule inside a red blood cell and transported back to the lungs in the blood like that. So 3% of waste CO2 is transported in the dissolved in the plasma, and 73% of it is transported as carbonic acid. So the acid in the blood makes the pH of the blood lower, so it becomes more acidic, and this change is detected by chemoreceptors. So the chemoreceptors will send feedback to the cardiac control center and the respiratory control center, and they will respectively make the heart rate and breathing rate increase so that the waste products can be removed from the muscles, and the body will get rid of the CO2 quicker. So lactic acid is another waste product that the body produces. It's produced in the lactic acids as a result of the lactic acid system working, and so mainly in anaerobic exercise, but a very small amount is produced in aerobic exercise. It can cause the glycolytic enzymes to stop working properly, and it causes an increase in acidity and a decrease in blood pH. So as workload increases, so does blood lactate, and the average person has a lactate threshold of about 2 millimoles, and as workload increases, more so does blood lactate levels. And at about 4 millimoles, the average person will reach OBLA, which is onset blood lactate accumulation. And at this, once you reach this point, your blood lactate levels will rise at a much quicker rate than the workload will rise. So you're not going to be working a lot, but you're going to get a massive increase in lactate. And this is because the lowering the lactate that you've produced will be in the blood, and this lowers the pH, which then causes the glycolytic enzymes to denature, which in turn means that anaerobic glycolysis can't be completed because the enzymes that are needed to complete the process are denatured and it doesn't work properly. Another waste product from the body is heat. So 80% of energy produced in the body in aerobic exercise is lost as heat. So only 20% of the energy we produce in aerobic respiration is used. The other 80% is completely lost and goes into the atmosphere. So the three main physiological changes enable the body to lose heat and keep homeostasis. And if heat is not lost, it can cause heat stroke, hypothermia, and heat exhaustion. The hypothalamus will detect that the body is too hot, and it will send signals to the cardiac control center telling it to lose body heat. So the cardiac control center will make arterioles and precapillary sphincters, which are going to the skin capillaries. It will make them vasodilate to bring more hot blood to the skin surface where the air is cooler, and the heat can then leave the body through conduction and convection. And also, the hypothalamus will make the body hairs lie flat to aid heat release via convection, and it will make the sweat glands produce a lot more sweat so that the body can lose some of its heat through evaporation. So